Hey guys, I also wanted to talking about how to figure out a min or a max um, of a function. So I know that was something you guys were really struggling with. So specifically, it's 1C and 2D. So before I even talk about those, though, I wanted to just talk about a couple of things in terms of min and max. So remember that in order to find a min or a max of a function, we have to find the critical points. Okay, and we know that critical points are where the first derivative is equal to zero or does not exist, right? So this is if we go all the way back to unit 5, when we first started talking about mins and maxes of functions, that's what we had to do. We had to find the critical points, which meant set it equal to zero or figure out where it doesn't exist. And then we had to do a sign chart, right? And then to find an absolute min or max, we had to find those critical points and then make an options chart to actually decide which one is the key. Okay. So if we're looking at an amount of stuff, all right, we said that an amount is equal to find an amount right now, right? We would do initial plus the integral of the rate in minus the integral of the rate out. So if we look specifically at number 2, okay, so if we look back at this question here about the people getting on the escalator. So if I'm going to write an equation for the amount, I'm going to call it A of t, just so I don't have to write amount each time. So A of t is going to equal the initial amount of people in line, so 20, plus the integral from 0 to t of the rate in, which is this r, so I'm going to call it r of x dx, and then minus the integral of the rate out, which is 0.7 dx, and that's from 0 to t as well. So this equation will tell me the amount of people at time t. All right, so that's actually what we use in part B then to get that there are 80 people in line at t equals 300. We would just plug in a 300 here and here, put it in our calculator, and we'd be good to go. But in part D, we're talking about finding the minimum number of people, which means we need to actually find the critical points of this equation. So in order to do that, we have to find the derivative of this equation. So a prime of t is going to equal, well, the derivative of 20, because 20 is a constant, that's just 0, so it goes away. Then if I want to do the derivative of this integral, this is going to be that fundamental theorem of calculus. So we would do plug in the upper bound, so it'd be r of t times the derivative of t, which is 1, minus plug in the lower bound, r of 0 times the derivative of 0, which is 0. So this is the part that just goes away, right? Because it was a constant. But this right here is just the derivative of that integral. So then I can do minus the derivative of this integral. So it's going to be 0.7. And for this one, there is no plugging in t or 0 because there's no variable here. So this one is just minus 0.7, which means what we really get down to is that a prime of t is r of t minus 0.7. And this is actually always what happens when we do these rate functions. Okay, if we're trying to find the first derivative, right, or the derivative of the amount, then it's always going to come out to the rate in minus the rate out. That's always going to be what your first derivative equals. And so that's why on some of the answer keys, jump right to just, if we're doing a min or a max, a lot of times we just jump right to this step. 0 equals the rate in minus the rate out. But this is kind of the work that comes from it. So hopefully that makes a little bit more sense. So back to this question then, if I want to know when the number of people in line is at a minimum, then that means I need to know when is r of t minus 0.7 equal to 0. So that's the rate in minus the rate out. When is that equal to 0? Because this is going to give me those critical points. All right, so then I'm going to need my calculator, which I need to grab. I don't know where I put it. Okay, I found it. Okay, so then for this, hopefully, nope, this is a different function. Okay, so let's go ahead and plug in r of t. So 44 x over 100 raised to the third. Whoops, raised to the third. I don't know what I did, you guys. Okay, 40 might help if I actually use the fraction button then, since I hit it. Okay, 1 minus x over 300 raised to the 7th power. Okay, so that's r of t, right? And so really, if I look at this equation, I'm really looking for when is r of t equal to 0.7, because for me, that's easier to do. So I just plug in this to y1, plug in this to y2, and I'm going to find their intersection point. So let's check out my window here. I need to go from 0 to 300. And since I'm looking for where it's going to equal 0.7, I think for my y values, I'm just going to go from 0 to 1. All right, let's see what happens. Okay, so when we look at this one, we can see that that horizontal line there, that 0.7, is crossing r of t twice. So we need to find both of those intersection points. So we're going to go to second trace, and we're going to calculate an intersection point. So for my first curve, let's see, I'm going to go over to here. Okay, so first curve, second curve, tell it to guess. All right, so that first intersection point is 33.013. And then we need to find the second one. So second trace intersect. Now I need to scroll over to the other side so that I can hopefully figure out what that other one is. I think I'm getting close, maybe. Oh, yep, there we go. Okay. So first curve, second curve, tell it to guess. So 166.575. So those 2 points right there, these are my critical points. Which means now what I need to do is I need to make an options chart to help me figure out where is the actual minimum and what is the minimum. So I'm going to make an options chart for t and the amount. In your chart, you always have to include your endpoints, so 0 and 300, and then we're going to include both of our critical points. So 33.013 and 166.575. I'm not going to spend the video going through how to put these in the calculator, but what you are going to do is you are going to use this equation that we wrote right here, right? The same one that we used for part B. And all you're going to do is plug in the correct t value that you are evaluating it for. All right, hopefully that makes a little bit more sense on how to figure out the mins and maxes for these problems.